Proving trigonometric identities. Now, under this umbrella, there could be several problems, and some problems could be hard, some could be easy. Now, the more trigonometric identities you remember and the more comfortable you are with algebra, that's going to help you. The easier it gets to prove trigonometric identities. So I have some general recommendations, and here is the first recommendation. Change all the trig functions to sines and cosines. So if you see cosecant, then write as 1 over sine. Secant is 1 over cosine. Tan is sine over cosine, and cot is cosine over sine. And again, you don't have to always do this, but generally changing to sines and cosines will make the problem a little bit simpler. Now, the second recommendation is be sure to remember this Pythagorean identity. Since we are converting everything to sines and cosines, then you also want to know that sine and cosine are related by this equation. Cosine square theta plus sine square theta equals 1. Now, if you remember the other two Pythagorean identities, that's going to be great. The other two are 1 plus tan square equals secant square and 1 plus cot square equals cosecant square. But even if you don't remember those two, at least know this one. Then the third recommendation is not from trigonometry, but from algebra. Remember the difference of squares formula. A minus b times a plus b is equal to a square minus b square. And if you don't recall this, you can quickly use the FOIL method to multiply and see that the middle two terms cancel each other out, and then you are left with just a square minus b square. And finally, if you have to combine two fractions, I wrote to combine two fractions, you can cross multiply to get the numerator and multiply the denominators to get the denominator. So if you have to add two fractions or subtract, you might know to take the common denominator and then divide each of the denominators. You could do that, but the other thing you could do is simply cross multiply. So if I have a over b plus c over d, I'm going to go this way, ad plus bc. That's going to be my numerator. And then the denominator is just multiply the denominators to get the denominator, meaning you multiply just the b and d. Now, if I have a plus here, I'll have plus over there. But if it is a over b minus c over d, then it's going to be ad minus bc over bd. I did not write that, but you can use that. Now, let's do some problems. So the first one I'm going to work out is this problem, which says proof secant x plus cosecant x over tan x plus cot x is equal to sin x plus cos x. Now, to prove this, I'm going to follow my recommendation. Change everything to sines and cosines, and then we can begin to see. So the left side does not look anything like the right side. So I want to rewrite the left side as much as possible. So left side is that, but remember, I have a fraction on the left side, and the numerator is secant, which is 1 over cos, and cosecant is 1 over sine. And then the denominator is sine over cosine, that's tan, plus cot is cosine over sine. Now I changed everything on the left side to sines and cosines. And let's see how this will work out. So this is going to be a complex fraction. Well, the numerator, remember, if you have to add two fractions, you can simply cross multiply. So 1 times sin x is sin x plus cos x. That's going to be my numerator. Sin x plus cos x times 1 is just cos x. And then the denominator is simply their product, which is cosine x, sin x. Similarly, in the denominator, I again have to combine these two fractions. So I'm going to cross multiply. Sin x times sin x is sin square x plus cos x times cos x is cos square x. And then divide by, how do I write the denominator? I simply multiply the denominators. Cos x sin x. So now I have to divide this fraction by this fraction. So that is same as keeping the numerator sin x plus cos x over cos x sin x, and then I have to flip this fraction and multiply. So this fraction flipped will be cos x sin x over sin square x plus cos square x, and you might actually recall. Now notice that we can cancel out, so I'm going to use a different color pen to cross out the cos x and cos x, then sin x and sin x. So notice what I'm left with is just sin x plus cos x in the numerator. And then the denominator is sin square x plus cos square x. That is just 1. So this is sin x plus cos x. Now that is equal to the right side. So we started with the left, we rewrote, then did all the operations, mathematically appropriate operations, and arrived at the right side. So we proved this. Let's do one more problem. And this time I have 1 minus cos x over sin x plus sin x over 1 minus cos x. Well, the question is, prove that this is equal to 2 cosecant x. And again, how do I rewrite my left side? So let's start at the left. Now the left side, everything is in sines and cosines, so there's nothing to be converted. But notice I have two fractions. So how do I combine these two fractions? Well, my final answer will be a whole big fraction, where the numerator is the cross product. I need to multiply 1 minus cos x from here with 1 minus cos x over there. And then there is a plus sin x times sin x. So that's going to be sin square x. And then the denominator is the product of the denominators. So that's going to be sin x times 1 minus cos x. Now it's time to simplify. The numerator, I'm going to copy the denominator because I don't want to break these factors. But here, look, there's a plus sign here, which means I need to expand this. So what do I get when I multiply 1 minus cos x with 1 minus cos x? I get 1 minus cos x minus cos x. So that is 1 minus 2 cos x. And then negative cos x times negative cos x is plus cos square x. So this is these are the three terms I get when I multiply these two factors. And then I have a plus, which I will copy, sin square x. And notice, cos square x plus sin square x is 1. So this is going to be 1 minus 2 cos x plus 1 over sin x times 1 minus cos x. So let's go ahead and simplify the numerator. It's 2 minus 2 cos x over sin x times 1 minus cos x. And notice we can factor a 2 in the numerator. Then you get 1 minus cos x divided by sin x times 1 minus cos x. Now we see a common factor of 1 minus cos x in both numerator and denominator. So we can cancel those two. And finally, we are left with 2 over sine x. But 2 over sine x is nothing but 2 times cosecant x, which is equal to the right side. And we proved the result.